Today we are talking about powers and exponents. And so the first definition, sorry, this is low. There we go. Okay, the first definition that we need to fill out is a factor. And a factor is an integer that divides into another integer with a remainder of 0. Okay, so for example, a factor of 12 is 4 because 4 goes into 12 3 times. Or 5 is a factor of 20 because 5 goes into 20 4 times. And so what we're going to talk about is using an exponent as a shorthand way of showing a product of equal factors. And an exponent is going to tell us how many times a number, also called a base, is used as a factor. An expression using a base and an exponent is what we call a power. So if you will look down here at this big 2, little 5, this entire thing, this whole thing in yellow, is called a power. And what it is made up of is a base of 2 and an exponent of 5. Okay, and the exponent is telling us how many times we're using the base number as a factor in a multiplication problem. So, for example, 2 to the 5th power means 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 2 times 2 times 2 times 2 times 2. Another way of writing that is 2 to the 5th power because it's 2 being used as a factor 5 times. So if you look down here at these 4 examples, okay, this one is made up of 3. And how many times am I using 3 as a factor? 2 times. And then 5. How many times am I using 5 as a factor? 3 times. Okay, and there's a special word for when you have an exponent of 2 and it's squared. So this is 3 squared, and if it's a 3, it's 5 cubed. Okay, so this is a B. Let's look at this next one. It's 4 squared x squared y. Okay, I don't have to put the little multiplication signs in between because it's implied when you have factors with exponents and they're next to each other without a symbol in between. It's implied that they're being multiplied together. Okay, so let's look at letter C. On letter C, we have 2 number 9s, so that's 9 squared, 4 C's, so C to the 4th, and then 2 B's, B squared. And then on this last one, I have 2 negative 3s, so we're going to put the negative 3 in parentheses, and I will explain that in just a second. Okay, but it's the quantity, the whole thing, negative 3 being squared, and then x to the 4th power. Okay, so again, hold on just a second, and as soon as we get to the next, or the back of your page, I will explain why I put that in parentheses. Okay, so on to this next page. So if you have negative 5 to the 4th power, it means that this entire thing, this whole parentheses, is being raised to the 4th power. It means that it's negative 5 times negative 5 times negative 5 times negative 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. And if we count those negatives, 1, 2, 3, 4, negative, negative makes positive, negative, negative makes positive, it's positive 625. Okay, because if we look at what this exponent was applying to, it was this entire quantity. Okay, but if we look at the next example, what is the exponent touching? It's only touching the 5. So it's saying like the fifth or the fourth power of 5, negative, or the opposite of 5 to the fourth power. Okay, this negative is not included in the exponent. So this problem means negative 5 times 5 times 5 times 5. 5 times 5 is 25, 125, 625. But in this case, how many negatives do I have? Just one. So it makes it negative. Letter G, negative 7, the whole quantity being raised to the third. Negative 7 times negative 7 times negative 7. So I know that 7 times 7 is 49, and then 49 times 7 is 343. And then is it going to be positive or negative? Negative, because I have 1, 2, 3 negative signs. And then let's look at letter H. This one means the opposite of 7 to the third. So the opposite of 7 times 7 times 7. So 343, and is this one positive or negative? Negative, because there's one negative. So the difference between this one and this one, or sorry, these two and these two, right, is that because this is an even exponent, it makes this product positive because there's an even number of negatives. Down here it didn't matter because it was an odd number of negatives regardless. It was either 3 or 1, but either way it was going to be negative. Okay, let's look down here and we're going to simplify, okay, and it says don't forget PEMDAS. So on letter I, within the parentheses, we have to do 2 times 5 first. So 26 minus 2 times 5 is 10 squared. And then according to PEMDAS, we did the parentheses, now it's exponents. 26 minus 100. And now I can do my integer rules, keep, change, change. They're different signs, subtract. 100 minus 26 is 74, and there's more negatives. So negative 74. Let's look at letter J. Okay, are there any parentheses? No. Are there exponents? Yes. So I'm going to do 3 squared first. So negative 4 plus 6 times 9 is 54. Different sign, subtract. 54 minus 4 is 50. Positives have the greater absolute value. Now let's look at K. So this one is 5 times x to the third, and x is negative 2. So I have to make sure that I'm taking the whole negative 2 to the third power. Okay, so negative 2 to the third power is what I'm going to do first. So let's think about what negative 2 to the third power means. Okay, it means negative 2 times negative 2 times negative 2. 2 times 2 is 4. 4 times 2 is 8, and it's negative. So I'm going to have 5 times negative 8, which is negative 40. Okay, and then on letter L, it's 5 times negative 2 to the third power. So in this scenario, right, I have to do inside my parentheses first. 5 times negative 2 is negative 10, and then negative 10 to the third power is negative 10 times negative 10 times negative 10. 10 times 10 is 100, 100 times 10 is 1,000, and it's going to be negative. And that's my answer.